بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Dear students of the General Secondary Certificate, welcome back to your program مدرسة على الهواء. Today inshallah we'll continue our discussion in chapter 4 about the galvanic cells and the standard hydrogen electrode. In the beginning, let's welcome your guest and my guest, Mr. Muhammad Abdullah Riyad. Welcome back, Mr. Muhammad.
Welcome.
Dear students, don't forget to get your copybook, your calculator, your pen, and we wait for your calls about chapter 4 or any question you want to have an answer for. Firstly, Mr. Muhammad, we'll continue our discussion about the galvanic cell.
Yes.
Okay. We'll start with the standard hydrogen electrode or the calculation of the EMF. Let's start with the standard hydrogen electrode. Okay.
We say that directly we can get the standard electrode of an element. So we use an element has a standard electrode potential, which is hydrogen, because the hydrogen has the standard electrode potential of hydrogen equal 0. But how can we make a half cell contains a hydrogen electrode? This is a diagram to explain the structure of hydrogen electrode. We get a platinum sheet. The area of the platinum sheet 1 square centimeter. This is platinum sheet. Why? Because the platinum has the ability to absorb, to collect the hydrogen gas on its surface. Then we get a solution contains hydrogen ion, any acid such as HCl, H2SO4. This hydrogen acid by the concentration equals 1 molar solution. So here the two parts of two terminals of the hydrogen electrode. Platinum sheet which absorb hydrogen, but we have hydrogen gas, and then hydrogen ion which is the acid. Take care, and we get the hydrogen gas. The pressure of the hydrogen gas must be 1 atmospheric pressure. This is the source of hydrogen gas, 1 atmospheric pressure. This hydrogen gas is collected on the surface of the platinum sheet, absorb the hydrogen gas on a platinum, absorb hydrogen gas, and this is the hydrogen ion from the acids. The standard electrode or the potential electrode of this hydrogen equal 0 must be the atmospheric pressure of hydrogen equal 1, and the concentration of the ion will be 1 molar solution. When we connect this hydrogen electrode, and this is the wire, and we connect it by voltmeter, and another electrode, maybe zinc, copper, the electrode which we want to, or the element which we want to get the standard electrode of it. So the voltmeter gives the difference between the two electrodes. The hydrogen equals 0, so the reading of voltmeter indicates the electrode potential of the other elements. This is about the standard hydrogen electrode. Why we take it to get the standard electrode of another element? Because the standard hydrogen electrode equal 0.
So dear students, take care about the questions come in this part. Actually, you have to learn how to draw it as your teacher showed it. It's a simple drawing for the standard hydrogen electrode. Number 2, you must know that at these conditions only, which are 1 atmospheric pressure hydrogen gas and 1 molar hydrochloric acid, at these conditions only, the standard hydrogen electrode equal 0. Number 3, what do you need to know about this part? Why we use it? We use it to know or to measure the potential of other elements. It's not the one that the voltmeter measure the potential difference by using the standard hydrogen electrode, which has the potential 0. So the reading of the voltmeter will be the potential of the other element. So these 3 points are important: the conditions, the uses, the drawing. All of these points are you have to learn to draw to answer this part in the to answer the questions on this part. Thank you, Mr. Muhammad. Sorry for interruption.
And the number 4 is the half cell of hydrogen electrode, PT by hydrogen gas, 1 atmospheric pressure, 1 atmospheric pressure, and hydrogen ion 2 H positive 1 molar. This is the expression of the half cell of hydrogen. Okay, and it is equal 0.
This part as the hydrogen as anode.
Yes.
So could you show us if the hydrogen is the cathode, how can we write the symbol? Yani this part that you draw,
Yes,
it's
it
the anode.
will be the cathode. We know that if 2 hydrogen positive 1 molar converted into hydrogen H2 1 atmospheric pressure over platinum. This is when we use it as a cathode, because the cathode on reduction occurs at cathode to convert from positive hydrogen ion to hydrogen gas. Okay, let's to take an example. Do you have an example about the hydrogen to get EMF?
To calculate the EMF or
Yes.
the potential of other elements.
Yes.
Okay, suppose we connect the hydrogen with zinc, and we need to determine the potential of the zinc.
Yeah, but we want to get the
Potential of the zinc. And they will not mention in the question the hydrogen electrode potential, because all of us know that it's 0. So he will not mention it in the equation or in the question. If the EMF of the cell, yes, if EMF of the cell is positive 0.76 volt.
76 volt.
Calculate the potential of zinc. We need to know the potential of zinc.
We know that EMF equals, I said that, difference between the two oxidation starting with the anode, or the difference between two reduction starting with the cathode, or the oxidation potential of anode plus reduction potential of cathode. Again, if the difference between the two electrodes, the difference between two oxidation, I start with the oxidation of anode. If we use the difference between the reduction of the two electrodes, we're starting with hydrogen. We're starting with cathode. If I get the EMF by the oxidation potential of anode and the reduction potential of cathode, we know that from the electromotive series, zinc before hydrogen, so it has higher oxidation potential. So in this cell, zinc will be the anode and the hydrogen will be the cathode. So the cell diagram is zinc will be converted into zinc positive 2. Oxidation, this is the anode, and the oxidation occurs. This represents the difference between the two half cells, or the cell diagram, the galvanic, the salt bridge. And here a hydrogen, we said that 2H positive is converted into H2 gas. This is the cathode. So EMF will be oxidation potential of zinc, because it is the anode, plus reduction potential of hydrogen. Hydrogen is the cathode. EMF equals positive 0.76. It will be zinc oxidation potential of zinc plus 0. So oxidation potential of zinc equals 0.76 volts. This is how to get the oxidation potential and how to write the expression. Take care, this is the anode at the first, and the oxidation occurs at the anode. So it's converted from 0 up to positive because it loses electrons. This is the cathode. The cathode is converted from positive ion to 0 because the reduction occurs at the cathode. So hydrogen here, hydrogen ion is the oxidizing agent and zinc element is the reducing agent. Okay, let's go with the type of galvanic cell.
We know that there are two types of galvanic cell, primary and secondary. primary cannot be recharged, so they only convert from chemical energy to electric energy. While the other type, secondary, can be recharged, so change from chemical to electric and vice versa. طبعا عندنا two examples للبرايمري cells و two examples للجلفانيك cell للسكندري cell. انا اسفه. خلي بالكم ولادي ان الجزء ده فيه اجزاء جديده علينا في المنهج، بمعنى ان احنا عندنا في البرايمري cells في عندنا يعني المفروض ان احنا بندرس الميركوري سيل، وده اكزامبل كان اوريدي زمايلكم بيدرسوه السنوات السابقه. وفي عندنا كمان الفيول سيل ودي جديده. وطبعا احنا عارفين ان كل الاجزاء الجديده تخلي بالكم منها كويس جدا. ليه؟ لان الاجزاء الجديده ان شاء الله شور هتسالوا فيها، لانه هيبقى يعني زي ما بيقولوا كده ارض خصبه جديده للاسئله، سواء لوضع الاسئله او للمصحح. فلو سمحتوا الاجزاء الجديده اهتموا بيها كويس جدا، وتاكد ان انت معاك طبعه كتاب السنه دي من كتاب المدرسه، لانه طبعه السنه دي مختلفه تماما عن طبعه السنوات السابقه. بالنسبه للسكندري سيلز، الحقيقه احنا عندنا الليد اسيد باتري، ودي اللي هي من البطاريات الهامه جدا اللي هي الكار باتري، وعندنا الليثيوم باتري ودي جديده برضو. فنخلي بالنا من الاجزاء دي، مهم قوي الرسومات، مهم قوي الايكويشنز، مهم قوي الاي ام اف بتاع السيل، مهم قوي عند الانود الاكسيديشن ايكويشن عامله ازاي، وعند الكاثود الريدكشن ايكويشن عامله ازاي. ان شاء الله لما هتتابعوا استاذنا هتلاحظوا ان هو بيهتم قوي بالاجزاء دي. احنا دلوقتي هنبدا في زي الجلفانيك سيلز انواعها.
اوكي. الحقيقه المس منشن ذات البارتس نيو. طبعا all the curriculum is new for you, but about the old book اللي عنده كتاب قديم take care ان في حاجات مضافه كتير، فلازم يكون عندك طابع السنه دي. الجلفانيك سيل we said that it converts chemical energy into electric energy. الجلفانيك سيل there are two types of galvanic cell: primary, which cannot be recharged; secondary, can be recharged. Primary cell such as mercury cell and fuel cell, while secondary cell can be recharged, so they can act as galvanic cell or as electric cell, such as lead acid battery or car battery or lithium ion battery. Let's see the first mercury cell. This is a shape of the mercury cell, and I will be write assemble parts of this cell. The mercury cell, it is made of anode, which is an anode part over part. This is the anode. The anode is made of zinc, while a cathode, it is made of mercury oxide, HgO. And between them, the separated between them, it is the electrolyte, which is KOH, potassium hydroxide, a strong electrolyte. And this is closed by steel carefully, because it gives the mercury, which is poisonous. So we must get rid of this cell by safety way, because it contains poisonous substance. I can write this by symbol. This is the anode. I said anode is zinc, and this is a cathode. Anode, cathode HgO. Between them electrolyte, which is electrolyte KOH, and this must be closed carefully, because it contains them. This is a symbol diagram for this, the mercury. The same. Anode, cathode, and separator is the KOH. What's about the equation which occurs in this cell? Zinc is oxidized to be zinc oxide. Zn plus HgO, it gives ZnO plus Hg. Zn0 is oxidized to be Zn positive 2, and combined with oxygen to be ZnO. So oxidation occurs to the zinc. While HgO is reduced, Hg positive 2 is reduced to Hg0. This is reduction occurs to the zinc. and the EMF of the cell equals 1.35 volts. This is about the mercury cell. Number 2, fuel cell. The fuel cell, this is the example of the fuel cell. It contains two cylinders, and the fuel of this, the electrode and the anode, is the hydrogen gas and the oxygen gas. The first one in this tube, we put the hydrogen gas, and the second an oxygen gas, and the water, because the water is hydrolysis to give the hydrogen and the oxygen. So we add continuously a hydrogen, cylinder by hydrogen, to let this cell continuously work. It doesn't stop and recharge. This is a hydrogen which acts as the anode, separated from the electrolyte, which is KOH or NaOH, by a porous layer of porous sheet of carbon, to let the hydrogen ion pass to the electrolyte and prevent moving of the electrons, because the electrons is transferred to the outer circuit. And here oxygen gas. Hydrogen ion. Hydrogen is oxidized. We said that oxidation occurs at anode. Hydrogen is oxidized to form hydrogen ion, which at the end combine with oxygen to form water. So it gives water. So we can use this as a pure water. Okay, let's say the equation which occurs at anode and at cathode. Hydrogen from anode lose 2 electrons if we get 2 hydrogen molecules as a form of gas, and it is oxidized to hydrogen positive ion, passes from the separator to the electrolyte, combine with OH, 4 OH negative ion, to form 4 molecules of water, and gives 4 hydrogen ion due to the oxidation of hydrogen gas. At cathode, also separated by a porous layer of carbon and contains oxygen gas. Oxygen is reduced by the electrons, comes from the anode by electrons in the presence of water to form 4 OH negative, oxygen gas, O2 oxygen gas, plus 4 molecules of water, plus 4 electrons. Reduction occurs to form 4 OH negative. The oxidation potential of the anode equals 0.83 volts, while the reduction potential of the cathode is 0.4 volts. The total reaction will be hydrogen gas, oxygen gas, 4 OH negative, cancel with 4 OH negative. This is the input and this is output. And here 4 H2O and 2 H2O. So hydrogen combined with oxygen to form 2 hydrogen. The EMF of this cell will be 123 voltmeter. I say that it works continuously, but we give cylinder of hydrogen in order to let this go. We can get another source of hydrogen, maybe the gas, such as methane gas or carbon monoxide, which combine with water to form carbon dioxide and hydrogen. So it is the source of hydrogen and the oxygen of the air, and it gives water. We can use it for drink. So it is used in rockets and ships, space ships. This is about the fuel cell. Yes.
Actually, about the fuel cell, dear students, take care about something. Number one, there is a difference, as your teacher said, في difference ما بين الفيول cell بالرغم انها primary cell وبقية primary cells. Primary cells cannot be recharged. والفيول cell حقيقة cannot be recharged برضو، او ما بتحتاجش تعمل recharging. ليه؟ لان في outer supply. طالما في outer supply للهيدروجين والاكسجين، يبقى انا كده ضمنت انها هتفضل شغالة. الاختلاف الثاني انها ما بتعملش ستور للكيميكال انرجي ان فورم اوف الكتريك انرجي. ليه؟ لان التفاعلات شغاله على طول، فما بتعملش ستورج للكيميكال انرجي ان فورم اوف الكتريك انرجي، مفيش الكلام ده، او الالكتريك انرجي ان فورم اوف كيميكال انرجي، ما بيحصلش، لان التفاعلات على طول مستمره فيها. كل دي تعتبر advantages للفيول سيل، انها بالرغم انها cannot be recharged بس في نفس الوقت هي can work for forever يعني as there is outer source of supplying of hydrogen and oxygen. الحاجة التانية ما بتعملش store للانرجي. الحاجة التالتة ان الووتر released منها انها can be used طبعا بتبقى vaporized water can be condensed and used as source of water for the astronauts، لان استاذكم قال انها بتستخدم في الروكيتس والسبيس شيب، فانا ممكن من الفيول سيل دي اطلع مصدر ميه متجدد ونضيف للاسترونوتس. الحقيقه النقطه الرابعه انها doesn't pollute the environment، مش ملوثه للبيئه. ليه؟ لانها البرودكت بتاعها ووتر، والووتر حاجه من البرودكتس اللي ما بتلوثش البيئه. يبقى كل دي مميزات للفيول سيل تحطها في بالك، عشان لو اتسالت what are the advantages of the fuel cell، طبعا الجمله مش مكتوبه كده ان ده من المميزات، لا انت بتستنتجها من سياق فهمك لموضوع الفيول سيل. وخلي بالكم الفيول سيل من الحاجات اللي هتخشوا ان شاء الله السنه دي تلاقوا عليها اسئله في امتحان الثانويه العامه، ركزوا عليها لانها مهمه جدا. طبعا انا اسفه ان انا قطعت حضرتك، بس يعني حبيت ان انا يعني ابروز الكلام اللي حضرتك مهم قلته، لان ممكن الطالب يسمعه ويحس انه شرح، لكن يفهم ان النقط دي مش بس شرح، لا بيجمع منها.
Yes, okay. This is about the fuel cell. Let's to go to the another one.
اللي هم السكندري سيلز.
We said that secondary can be recharged, so we called it battery. These are accumulator. We can make the chemical energy stored in it, and then when we need it, we can take it as a source of electricity. So the battery can be recharged. For the first one is the car battery, which called lead acid battery. Lead acid battery. Lead acid battery. الانود it is a network of lead filled with paste of lead BB, and the cathode also network of lead and filled with paste of lead dioxide. Lead dioxide. This is about the anode and the cathode. These are found in container made of strong rubber, solid rubber, or polystyrene, because it resists the effect of heat and the effect of acids. Why? Because the electrolyte is sulfuric acid. Sulfuric acid. So the body of the battery, this is the body of the battery. Each two half cells, lead with lead dioxide, gives 2 volts. The battery can give the total EMF of the battery is 12. So it is made of 6 cells. Each one gives 2 volts, 6 cells. This is put in the container. This container has sulfuric acid, electrolyte, sulfuric acid. The concentration of sulfuric acid from 1.28 up to 1.30, 1.3 gram per cubic centimeter. If the concentration of the acid, as we know, decrease to less than 1.2, the battery must be recharged. And the lead is connected together to be the negative electrode of the battery, and the lead dioxide is connected together to be the positive. So it has 2 terminals of the battery, and negative which act as anode, while positive which act as cathode. This is a diagram or shape of the container of the car battery. We called it car battery because it is used, the common use of this battery in cars. But let's to say the equation which occurs in car battery at anode. At first, sulfuric acid is converted into H positive ion and SO4 negative. 2H2SO4, 2H2SO4 is converted into 4H positive plus 2SO4 negative. The reaction at anode will be oxidation. Lead plus SO4 negative 2 will be BbSO4 plus 2 electrons, and the oxidation potential will be 0.36 volts. This is the reaction occurs at anode. At cathode, يبقى here oxidation الانود. الكاثود يبقى عند الريدكشن عند الكاثود. البي O2 plus SO4 negative 2 plus 4H positive ion plus 2 electrons. Take care. At cathode, BbO2, SO4 negative 2, 4H positive, 2E negative. Reduction occurs to give BbSO4 plus 2H2O, where a reduction potential will be 1.69 volts. Let's explain what occurs at cathode in details. Here the oxidation potential of Bb positive 4. Why? Because the oxygen negative 2 with 2 oxygen يبقى negative 4, so it Bb positive 4. It is converted into Bb positive 2 and BbSO4. So reduction occurs because it takes the 2 electrons. 2 electrons take by the Bb positive 4 to Bb positive 2. Here we have O negative 2. In O negative 2, 2 atoms combine with 4H positive. Take care, 2 ion, 2 O negative 2 plus 4H positive 2, it gives 2 molecules of water. This is to have to explain what. So the total reaction will be Bb plus BbO2, lead anode, lead dioxide cathode, plus 4H positive plus 2SO4. This is the ions of the sulfuric acid. This is called discharge. It gives 2 BbSO4 plus 2 molecules of water. So when it gives the electricity, we call it discharge, and here it acts as a galvanic cell because it converts chemical energy into electric energy and gives the electricity. We can use it in the car. This is about the equation. And EMF will be 2.05 volts. 2 volts, approximately 2 volts. So we have 6 cells in the put of the battery. So 2 by 2, 6 by 2, a total of the battery, total EMF of the battery, 6 times 2 equals 12 volts. This is about the discharge of the battery. This battery can be recharged. When? I say that the density of the acid will be from 1.28 up to 1.3 gram per cubic centimeter. According to increase the water here from this equation, the density of the acid decreases. We can measure the density by hydrometer. So it is a device used to measure the density of liquids. If the density decreases less to be less than 1.2, according to the accumulation of water from this equation, we must recharge this battery. Or when the lead and the lead dioxide decreases. Why? Because they are converted into BbSO4 lead sulfate, so we must recharge the battery. How can we recharge the battery? Recharge the battery so the battery acts as electrolytic cell because it needs outer source of electricity. It needs outer source of electricity. Here is the recharging the battery. We connect the battery by a source of electricity. The EMF slightly higher than the EMF of the battery. It will be converse the reaction. The 2BbSO4 plus 2H2O recharging is converted into Bb plus BbSO4 BbO2 plus 4 hydrogen or plus sulfuric acid plus 4H positive plus 2SO4 negative 2. Here it is act as the electrolytic cell. So battery can act as the galvanic cell when it gives electricity during discharge, and can act as electrolytic cell during recharging. We can write these two equations: Bb plus BbO2 plus 4H positive plus 2SO4 negative 2, 2BbSO4 plus 2 water. Here discharge, and here recharge. This is about the car battery. Let's transfer to another battery, which is the lithium-ion battery. Lithium-ion battery. Here is the lithium-ion battery. The lithium is carried to anode and the cathode. Anode is the carbon. This carbon contains combined with lithium. So the anode will be lithium LiC6 solid. Lithium carbon, lithium carbide. Graphite. This is the anode, contains lithium. And the cathode will be lithium metal oxide, such as LiCOO2 or LiNiO2, whatever. Lithium metal oxide. This is the anode. Lithium metal. Here is the cathode. Anode will be LiC6, for example. And the cathode will be LiCO cobalt oxide. What happened at anode and what happened at cathode? But take care, the lithium is converted between the anode and the cathode. Yani carbon here combined with lithium to be LiC6 and act as anode. And when discharge, the lithium transfer through the separator. Separator, it is from substance allow the ion to be passed from the two solution, and here the electrolyte to allow the ions to pass from anode to cathode and from cathode to anode. When lithium ion leave the electrons and transfer to the cathode, it combine with COO2 cobalt oxide to be LiCOO2. And during charging or recharging, the lithium remove and transfer, remove the cathode and transfer from LiCOO2 to the carbon to be COO2, and the carbon will be LiC6. So the equation will be at anode LiC6 solid oxidation, so the lithium will be oxidized, carbon solid added, Li positive and 4 and 2 and 1 electron. 1 electron. And then COO, I said that the cathode will be COO2. When we combine with oxygen, it will be lithium cobalt oxide plus electron, يبقى COO2 plus electron plus lithium ion. Reduction occurs, the lithium ion combine with electron to be lithium metal and combine with COO2 cobalt oxide to be LiCO, LiCOO2. This is reduction. And then the total reaction will be LiC6 solid plus COO2. I say that when the lithium combine again, when the lithium combine with carbon, it leaves the cathode. And when it leaves the anode, it transfers to the cathode. LiC6 is plus COO2 solid, discharge to give carbon and LiCOO2. And when recharging, LiCOO2 combine with carbon to be LiC6 plus COO2. Here is the transferring of lithium ion. The lithium ion during discharge, lithium ion transfer from anode to cathode. Why recharging or charging? The lithium ion from cathode is transferred to the anode. And the total EMF of this battery will be 3 volts, 3.5, 3.7, about the type of the component of this lithium battery. This is about the lithium battery, and here we explain that there are two types of galvanic cell. One cannot be recharged, called primary cell, such as mercury cell or dry cell or fuel cell, and another battery can be recharged and called the accumulator, because it can collect or can keep or can store the chemical energy in order to convert it into electric energy when we need it, such as a lead acid battery or car battery or a lithium ion battery. Another terminology in this part about the corrosion of metals. We know that 25%, 1/4 of the iron in the world is eroded, and this is a loss of big loss of economic. So we must keep the metals, keep iron from rusting. Let's to know what's meant by rusting, and rusting, how rusting occurs and why it occurs. Rusting meaning that erode or decay of the iron or of the metal. So when the metal exposed to an electrolyte contains iron, for example the water contains ions or oxygen in the air, it exposed to erode or exposed to rusting. So let's to know the most element which is exposed to the erosion, it is the iron. This is for the importance of the iron. Let's to see the mechanism of the iron by equation. The air, here is the, for example, a piece of iron, and here is some water contains iron, make as electrolytes, and oxygen. This acts as a galvanic cell. How this occurs? Iron is converted into iron positive 2. Iron is converted into iron positive 2 and lose 2 electrons. This is oxidation. Fe is converted into Fe positive 2 by lose 4 electrons. Positive 2 يبقى 2 atoms of iron is converted into positive 2. Oxidation. Oxidation occurs. And the oxygen is reduced to OH negative. The oxygen, 2 oxygen atom combined with 4 electrons and 2 water, 2 gives, let's to write the equation by big one. Iron at first, Fe, 2 iron solid, is converted into, by oxidation, is converted into 2 Fe positive 2 iron 2 plus 4 electrons. This is oxidation. The reduction occurs for oxygen O2 gas from the air plus 4 electrons to convert to O negative, which combine with 2 molecules of water. Each atom needs 1 molecule of water. Reduction occurs to be 4 OH negative ion, 4 OH negative ion, and this is aqueous because it is iron. So it is called reduction. So the iron is oxidized and the oxygen is reduced. Iron is oxidized to Fe positive ion and oxygen is reduced to be 4 OH, OH negative ion. Then iron combine with FeOH, iron ion, Fe2, Fe positive 2 plus 4 OH negative ion combine together to give FeOH all by 2 iron 2 hydroxide, iron 2 hydroxide. Iron 2 hydroxide is easily oxidized in the air. It is easily oxidized in the air. So Fe, 2 Fe, OH all by 2, iron 2 hydroxide is oxidized in the air in presence of water, H2O. Oxidation occurs to be 2 FeOH all by 3. FeOH all by 3. This is the type of the rusting. It will be iron hydroxide, iron 3 hydroxide. So the total reaction will be a total reaction for rusting. An iron 2 Fe plus 3 H2O plus 1.5 molecule of oxygen, 3/2 oxygen, it gives 2 FeOH all by 3, and this is eroded layer can be decay, causes what's called rusting. This is about the mechanism how the rust occurs. But iron is oxidized to iron 2, and oxygen is reduced to OH. Iron 2 ion combined with OH to form FeOH all by 2. And this is easily oxidized in the presence of air, in the presence of water, to give FeOH all by 3. What are the factors affecting the rust? Factor affecting rust or affecting corrosion, it may be refers to the metal itself or be referred to the media, the surrounding media. The surrounding media means that some salts in the air, some salts in the water, water with ions or oxygen from the air. And the other, I will explain. This is about factor specific due to the medium surround the metal, or the factor due to the metal itself. We know that iron is less active and it is slightly exposed to the rusting. but we use alloy. Alloy not homogeneous, slightly homogeneous alloy, but actually it is heterogeneous. It contains many elements. It contains large number. These many elements makes numbers of local galvanic cells. Local galvanic cells. Also, these cells, it may be of these elements and the alloy maybe comes from when cracking the base of the iron, alloy of iron, or in the welding points, or we using screws of different metals, screws. This causes different metals and the iron. So we have different electrodes, and the medium may be the water and the IV, so it acts as the galvanic cell. Also the iron can act as electrode itself. So these factors affecting or causes the corrosion. If factors due to the element itself, impurities found in the elements, this impurity may be more active than the iron. It will act as anode, and it is eroded the first and then the iron, or less active such as tin or another element, or copper for example. But this is eroded after the iron. The iron acts as anode in this case and is eroded. If this connection between, for example, aluminum and the iron, if aluminum more active than iron, it will be eroded at first. If it is connected with copper, with iron, the iron acts as anode and eroded at first. And another element, another factors, we said that the media surrounds the metal. This is how to protect the iron from corrosion. In order to protect the iron from corrosion, maybe covering the iron by another substance less active, such as covering the iron by oil. We'll explain about the alkane, heavy alkane. It is less active. We can cover it by alkane or by varnish or by primer, which is keep the iron from rusting, cover the surface. But it is not effective for a long time. Also, we can covering it by another metal. When we dip it in another metal, which is called galvanization. This galvanization may be by dipping the iron in zinc or in magnesium or in tin. I said that when we dip it in magnesium or in zinc, these are more active than iron. So it takes long time to erode the iron, because the zinc and the magnesium more active act as anode and eroded at first. But when we dip it in a zinc, in a tin, such as in canes, the tin is less active than iron, so the iron will be anode and will be eroded. There are two types of covering. We called it cathode cover or anode cover. Cathode cover, when this element is less active than iron, as example of tin. But the anode cover, when we use more active element, such as zinc or magnesium. So we call this is anode cover, because this element act as anode. When we use, for example, magnesium as anode, the magnesium act as anode and the iron act as cathode, and the magnesium is eroded at first. We call this sacrificial electrode, because it is decay at first, and then the decay occurs to the iron. This is how to protect the iron from rusting.
So this means that if iron is coated with tin, that the iron is protected, although it is anode, but because it is protected by the tin outside. But if there is any scratching on the surface of the tin, the iron will rust faster than iron pure, right?
Okay, the student may be asked, if this is less active than iron, the iron will be eroded, but it is covers the surface. When it is a scratch or it is removed or it is decay, it will be affect the iron, and the iron will be eroded because it acts as anode.
But if we cover the iron with zinc, there is something opposite here. The zinc will be always the anode and the iron will be always the cathode.
Yes.
So here is higher level of protection. Even if it is scratched, the iron will not rust because the zinc acts as the anode, right?
For example, this is the tube, underground tube. This is tube made of iron, Fe, and we get magnesium.
So the magnesium is the anode,
Mg.
so the tube is
then
the pipe
when
is
we connect it
with
with the battery, so it is act as cathode,
and the
because
magnesium
it is less active, and this is anode.
As you said us, it's sacrificial protection.
So it is decay at finish.
Thank you for being with us, Mr. Muhammad. It was a great honor and pleasure to be with you.
Okay.
Thank you, dear student, for being with us. We'll wait for you for the next session. Assalamu alaikum wa rahmatullahi wa barakatuh.